You multiply these?
No.
Can't read your mind. Guess? Okay. Did anyone else guess, or did anyone else have an idea?
Take the 12 and multiply by radical 2.
Take the 12 and multiply by radical 2. Why?
The hypotenuse is like 2 times the legs, if that makes sense.
Uh-huh. So this hypotenuse really has a coefficient of 1 in front of it, but we don't need to put that there because this is saying 1 times radical 2. 1 times anything is what? Itself. So this is keeping the ratio of we have the legs are equal to each other, and then the hypotenuse is the leg times radical 2. So if we keep that same idea consistent for this one, we'll be doing the same. These legs are equal to each other. So now the hypotenuse is the leg times radical 2. 12 times radical 2. And we can't simplify this down anymore, so that would be the length of our dashed line. Does anyone have any questions? Okay, so for the rest of the lesson today, we're going to be looking at similar word problems where we have to determine what side we're looking for and apply this concept of the 45, 45, 90 triangle. Okay, so these next couple slides are just going to be reinforcing the idea of this ratio. If we draw the diagonals, we form two 45, 45, 90 triangles. Using the Pythagorean theorem, we can find the length of the diagonal. So this proves the ratio that we just determined. If we had a square and had each of the side lengths to be 1, so that we get 1 squared plus 1 squared equals c squared, we're solving for the hypotenuse. When I actually work out all the math, I get 2 to equal c squared. Well, we learned yesterday to get rid of this squared, we have to find the square root. So we'll take the square root of both sides, so c is the square root of 2. So that proves our concept of the 45, 45, 90 triangle. Does anyone have any questions on that? One way we can use this when we're given word problems is we can check our work that way. So if we weren't sure if this answer was correct, we can put in 12 and 12 into our Pythagorean theorem and do 12 squared plus 12 squared and solve for c squared. And we will get 12 radical 2. That can be used as a check for our work. So conclusion, the ratio of the sides in a 45, 45, 90 triangle is 1, 1 radical 2. Okay, so in your notes, I want everyone to follow along on this, and we're going to fill in our blank space. It says, therefore, in all 45, 45, 90 triangles, the length of the blank equals the square root of 2 times the length of the leg. Does someone have any idea of what would go inside that blank? How do you say that word again? Hypotenuse. So everyone, pick up your pencils and fill in that blank. Doesn't that usually happen with birds? But you have to know this. Okay, can everyone look up here? I'm going to read out what this slide says. You don't have to write this anywhere, but I want everyone to just think about what I'm saying. This is going to help you when solving for problems. If we're solving for a missing side, and we're given the hypotenuse, and we want to find the leg, we're going to divide the hypotenuse by radical 2, and then simplify, because we can't have a radical 2 in the denominator. If we're given a leg and we want to find the hypotenuse, we know we can multiply the leg by radical 2. Are there any questions on that? No? Okay, so we're going to use this. We're going to apply these concepts now. Okay, so this problem is on the bottom of your worksheet. It's number 1. So let's work through the first one together, and then that second one you're going to work in your groups Okay, so the first one says Antonio built a square patio in his backyard. He wants to make a water pipe for flowers that go from one corner to the other. How long will that pipe be? Well, once again, we have our square, and it's asking us to divide it in half across one corner to another corner. So what kind of triangles will we be creating?
45, 45.
Thank you. So we will have to keep this ratio of what? 1 to 1 to radical 2. Okay, we want to know how long the hypotenuse is going to be, so we're going to be solving for this one. And it tells us that all the sides of this square are 17 feet. So if we pull out our triangle, we know that the side lengths stay the same because they come from the square. We have 17, 17, and we're solving the hypotenuse. 17 is our leg, so we're going to fill that in here, and we're solving for this. To keep this ratio consistent, what do we do to find the hypotenuse? Substitute what? For what? Go back to that sentence where I had everyone fill in that blank. I want everyone to take about 10 seconds and read that sentence to yourself. And then I'll ask the question again.
So
Read the statement to yourself. Okay, now I'm going to ask again. How can we find this hypotenuse length if we're given the length of these two legs?
the 17 times the radical 2?
Times radical 2. So the hypotenuse is always the length of one of the legs times radical 2. So to get this hypotenuse, if our legs are a length of 17, it would be 17 radical 2. And that's all we have to do. So even though there's a ton of words up here, this is all we have to do. Are there any questions on that? No? Okay, so take about 3 minutes, and I want you to work in your groups on the softball problem. It's number 3 on your notes. Don't go on. Yeah, don't go on. Did you do this one? And then work in your groups, see if anyone else.
What game is this? This is the same plan.
Well, you didn't even get the instructions yet. Don't go on. Follow along with the class, please.
Did I finish the one I was working on?
No.
I only had like
No, because you're going to ruin the game. Don't do it. The base is on the softball field to form a square. Go down to the center, highlight the square. The base is on the softball field to form a square. And the square length is 60 feet. Throw the softball from first base to third base. Look along with the picture. Throw it from first base to third base. How far do you throw the ball? So they're asking us what the diagonal is.
You think I can go next?
I have a question. So, a question like but you know baseball like double plays, right? Or that's what say, you know, she had a baseball. It's
Yeah, I
not
see.
perfect, but that's it. And you know, this is,
We're gonna take about 1 more minute. I want every group to come up with an answer. Does everyone see any
catch,
word?
right? Okay.
Come on, yes.
It's down first base, so it's still
Do you have an answer?
okay. It's still set.
We're not gonna play the game unless you guys.
Question is, we're gonna have hypothesis. Question is, how far is it from here to there?
Don't go on. It's part of
That's
the
how you
game.
gotta throw them out.
I incorporated it into the
You
game.
know what I'm saying?
We're going home.
So he's right here first base.
Okay.
How far is the pitch as the catcher can throw the ball? Catcher can throw him out. Okay? So first line, you get your answer. The legs are
I don't like the little things. What do you call it? I don't like it. Yeah, some multiply.
Okay, can I have eyes up here? 3, 2, 1. Whoa, we're kind of. Okay, so we're gonna go over this problem now as a class. It says the bases of a softball field form a square with a side length of 60. You throw a softball from first base to third base. How far do you throw the ball? Well, if we have this be home plate, this is first, second, third.
Pardon the interruption. Can I have Mr. Edward Baea to the office to go home for today, please?
Sure. Okay, so the question is asking us how far is first base to third base when the person throws the ball? Well, we have a square, we divided it in two, so what kind of triangles does this create?
45%.
Thank you. 45, 45, 90 triangles. And what is this dashed line that we just made also? What is this dashed line called? The hypotenuse. So what do we know about the hypotenuse? It keeps that ratio of radical 2 if our other two sides are 1. So if they tell us that the sides or the legs of this triangle are 60 and they're asking us for the distance from 1 to 3, what did everyone get as the length of the hypotenuse? Caleb, what'd you get?
I got 60 right.
60 radical 2. You too?
Yeah.
Good job. So the reason it is this is because we take, to find the hypotenuse, we take the length of the legs and multiply it by radical 2. Are there any questions on that? No? Okay, so we're going to do number 2 on the first page really fast, and then we're going to go on to a game. Okay, so number 2, everyone follow up here. It says a 45, 45, 90 triangle has a hypotenuse of 15. What is the length of one of the legs? So we want to know what these are. I'm going to wait till I have everyone's eyes up here. Thank you. So if we have the length of the hypotenuse and we're looking for the legs, let's go back to our ratio. We know that the hypotenuse is whatever the leg is times radical 2. In this case, we have what our hypotenuse is, but we don't know our leg, so let's we write this out into a formula, we can figure this out. So this is on everyone's note page. You can follow along with this. We know that the hypotenuse is 15. We're looking for the leg, so we can put an x. And we know that it has to be x times radical 2. Close. So if we're solving for x, our goal is to get x alone. X is multiplied by radical 2. How can we move that radical 2 to this side to get x alone? Divide. So let's divide by radical 2. These will cancel out. So now we have our leg to be 15 over radical 2. Seems like the answer, but it's not, because we can't have a radical in the radical in the denominator?
Don't you multiply by
Yes, we'll multiply it, the whole thing, by radical 2 over radical 2. Now we know when we multiply fractions, we multiply across the numerators and across the denominators. So our numerator is going to be 15 radical 2, and our denominator becomes radical 2 times radical 2, which is 4. And what's radical 4 equal? 2. So our answer is 15 radical 2 over 2. And that is the length of each of our legs. Are there any questions on that? No? Okay. So what we're gonna do now is put all this together and play a game of bingo so we can get some practice in. So everyone turn their page to their bingo card. So everyone's bingo card is blank. Usually bingo has some numbers on the inside, right? So what we're going to do is I put a list of all the possible answers of the questions that I'm going to ask during this bingo game on the board. I want you to take each of these answers and arrange them however you want on your bingo card. They can be in any order. Keep the free space where it is, but make sure you have every answer somewhere. You can't repeat an answer. Take about 30 seconds and fill in your bingo card.